and I have negative 108 divided by x. Okay. Second table, and I'm looking for positive 12, so I've got to go up to find positive 12. Oh, there it is. So negative 6 and positive 18 are my numbers, negative 6 and positive 18. The order doesn't matter. Okay. Now, what is my middle variable? U. Okay. So usually it's x, but you know, you use whatever it is because this is a not equal to 1, so we are not done. This magic pair of numbers is your split middle coefficients. Okay. So I rewrite this as 4u squared. Which one should I write first? Yeah. I don't have to, but it certainly makes life a little easier, keeping that plus in the middle. I do a quick check just to make sure I didn't change the value of anything. Yep, that equals positive 12. I put up my groups. Take out a 2u here. Take out a 9 here. 2u, leaving behind 2u minus 3, plus 9, leaving behind 2u minus 3. Big GCF. I'm doing this part really quick because this is more about showing the substitution. Okay, and then the leftover bit, 2u plus 9. Okay.
Okay, so basically you make up the rules for the U.
You substitute, yes.
Yeah, but I'm saying.
But the rules are very strict. It's not like you just make them up willy-nilly. The rule says your u is your middle variable.
Wait, but for my math lab, would you change it back to x?
Absolutely. And for me too. I mean, this is, you just made a u substitution because this is uglier to factor. But by making a u substitution, now you have a nice clean quadratic that you can use your method, your quadratic methods for. But in the end, you're not asked to factor this, you're asked to factor this. So now your final answer is.
Oh, so you can't use that. That wouldn't be the answer.
No.
You have to change those variables.
Anywhere you see, just like whenever you saw an x cubed, you put in a u. Now whenever you see a u, you put in an x cubed.
Okay, so it'd be
Yeah.
2
X cubed minus 3
Okay, this is so.
plus 9. Yeah.
I didn't know you had to do that though.
Yeah. Mm-hmm. Make sense?
Yeah, it did.
Wait, does everyone use the u or is it just you?
Specifically.
You can use whatever letter you want. Is that what you mean?
Yeah.
Yeah. U substitution is a very typical math thing to do. In fact, that's very much a term when you get into calculus. Okay? So I use it just to be consistent because a U substitution, it's a typical letter to use in substitution. But really, the whole point is the substitution is to make it easier. If you wanted to use a Y or an M or a, you know, it doesn't matter. Okay? U is just a consistent thing that you will see later on in other levels of math. So I'm being consistent.
Are we going to have a problem where U squared doesn't equal to the first?
Yeah, if you have U equal to your middle variable and when you square it, it doesn't equal your first variable, then it is not quadratic in form. Yeah.
So then,
Yeah.
You would have to
Then-
use other substitutes.
Well, then you're done.
yeah.
Yeah, you can't factor it. You can only factor quadratic trinomials. Okay? So if it is not quadratic in form, then you can't factor it. I mean, maybe there was a GCF, you know, so I can't say across the board you never can factor. There may be a GCF, but you're not going to be able to factor it into two binomials if it's not quadratic in form. Okay? And that's only the case if your u equals the middle variable and your first variable is your u squared. Then you plug in the u and u squared, use your quadratic method for a equal 1 or a not equal to 1, but then don't forget you have to substitute back. Yes?
And the reason why you didn't divide it by a -9 was because it was a positive 18, right?
Correct.
Right.
Because I had a plus in the middle, my leading positive GCF.
Right.
Yeah.
But when you divided it by 2, oh, because, okay, hold on.
You see?
Yeah.
Okay. All right. So our next one is a substitution also, but where we have not just a 6 and a 3 or a 4 and a 2, but where we have a chunk, okay, a binomial. So it's a really good example of the other type of substitution you're going to see.
And that's 9.2.
This is number 10. Yeah, 9.2, 9.3. That's the, yeah, number 10. All right. So my numbers are 2 times x plus 4 squared plus 3 times x plus 4 minus 5. Now, here's some clues. How many terms do we have?
5.
Mhm.
1, 2, 3.
3. 3. Because anything that's locked up, see, this is 2 times this squared. That's 1 term. Yeah. This is like saying 2y squared. But y, instead of just being a plain old simple y, is x plus 4. Okay? It's a big chunk. Anywhere you've got free floating, pluses or minuses are what separate your terms. Okay? So this is a trinomial. Now this one does, as opposed to having a 4 and a 2 or a 6 and a 3, this one has a 2 and a 1. This one is quadratic and linear and constant. Okay? So yeah, my last thing is constant. That's important. And I do have the quadratic and linear. But instead of having a simple x, I have a binomial. Okay? So that's really messy and ugly to factor. Okay? This is quadratic. We'll call it quadratic in form because we're going to use a substitution to make it cleaner and easier to look at. Okay? So what is my u? Right. Remember, it's just the middle variable. And the middle variable is this whole chunk. Keep it in parentheses. Okay? Now, if you square both sides, does that equal your first variable?
Yes.
Yeah. Okay? If these binomials don't match, then you're out. Yeah. Okay? So, you've got your u here and your u squared here. So you rewrite this. Notice I didn't involve any of my numbers, my coefficients of 2 and 3 or my constant of -5. Okay? This was just middle variable is u, square it, you get your first variable. It is quadratic in form. So rewrite this.
X plus 4 squared. Or no, why did you do that?
Because x plus 4 is equal to u. We set u equal to our middle variable.
Are you doing?
And so anywhere we see our x plus 4, we write a u instead. Where we see x plus 4 squared, we write u squared instead. So this is 2u squared. This is 3u minus 5.
To make it more simple.
Yes. Now I can look at that and go, oh, that's an a not equal to 1 trinomial. At least the numbers are pretty manageable. I can probably get away with not using my calculator here. My AC is -10, and my B is 3. -10 and 3. And my sign pattern is 2 pluses, 2 minuses, or a mix? Mix, right? So I've got 1 plus and 1 minus. So there aren't many factor pairs of 10, so I should be able to do this without my calculator. What would multiply together to make -10 and add to make 3?
5 and 2.
7.
No. Got to multiply 5 and 2, right? And which one's negative?
The 2.
The 2, yeah. Okay? Because that's why, and then just do a quick, this x is about helping the eye check that these numbers work. 5 times -2, check. 5 plus -2, positive 3. Okay? So, but this is a not equal to 1, so we are not done. What's our middle variable?
U.
U. Okay, so I tack on a u to those, and I split my middle. 2u squared plus, actually, I should do minus 2u first, and then plus 5u, to keep my plus in the middle. Because if I put the minus in the middle, I have to do that sign flip and the negative GCF. Why make my life more difficult if I have a choice? The order doesn't matter. These add up to 3u either way. And then minus 5. If you wanted to write it as plus 5u and then minus 2u, that's fine, but then you have to change that to plus a negative 2u and then take out a negative GCF. So it's an extra step. No. Okay. So because I kept that plus in the middle, I can put my groups up right away. Take out a 2u here. Take out a 5, positive 5 here, because I didn't have to make a sign flip. So 2u, leaving behind u minus 1. Pull out the plus 5, leaving behind u minus 1. Big GCF of u minus 1, leaving behind out of each term a 2u and then a plus 5. Now I'm going to wait for that kind of fast, because that was just our a not equal to 1 factoring. That's what we just need to practice and get fluent at. But now the substitution, this substitution is a little uglier to substitute back. Okay? But just think of it this way. You are just literally substituting. Wherever you see a u, what are you going to write instead?
Whatever you substitute there.
Exactly that. Yeah. Okay. So, we are going to write,
2 parentheses x plus 4.
well, right, this is our u answer, right? So right here, u minus 1 means we have x plus 4 minus 1. Okay? So this is u minus 1. And then my second binomial is 2. This one has a coefficient, u Look how important these parentheses are. Plus 5. So u minus 1, 2u plus 5.
Oh, I did it backwards. I flipped it around.
Okay. You see what you did?
Yeah.
Yeah. Okay. So now there's nothing to distribute here, so I can just drop the parentheses and have x plus 3, because positive 4 and negative 1.
You can do it.
Yeah. If there's nothing to distribute, those parentheses were to protect it and to keep it as one group now, but now that we're ready to simplify, we're going to combine like terms. If there's nothing to distribute here, there's no negative in here or another coefficient. This is just x plus 4 minus 1, and 4 minus 1 is 3. But here, I have to distribute that coefficient of 2. So I got 2x plus 8 plus 5, or 2x plus 13.
Hold on just 1 second. Wow. I know that one got me. I think that one really got me.
Okay. Is it the substituting back?
Yes.
Okay. This, take a breath. Don't overcomplicate this. You've done substitutions before in a different context. When I say here's a polynomial expression, what if x equals 3? Then you put 3 in parentheses and you put it in everywhere you see an x, right? And then you just use your order of operations and simplify. That's evaluating a polynomial, evaluating an expression. What if x equals this? Not something you can solve with an equal sign. You're just like, what if x equals this? Well, you plug in the x, and then you simplify. Okay? This is the same thing, just different context. You've already decided at the very beginning that u equals this. That means this equals u. Okay? So it doesn't matter whether you write a u or whether you write x plus 4. They have the same value because they are equal. So when you do your factoring with the nice clean u, u means x plus 4. So write exactly what you see here, but everywhere you see a u, and we always say whenever you make a substitution, keep it in parentheses. And this one already is. So u minus 1 is just x plus 4 minus 1. Literally taking away the u, anywhere you see a u, and this was 2u, so it's 2x plus 4 plus 5. Okay? These two things are equal, so you're literally just writing x plus 4 instead of u. And now you're using your rules of simplification. Things that you already know and have known for a while sometimes look weird and more complicated when you use them in a different context. But you know how to simplify this. X plus 4 minus 1. I don't need the parentheses because there's nothing to distribute, so I just combine like terms. 4 and negative 1 are like terms. Here, I do need the parentheses because I have to distribute that 2. You know how to distribute, 2x plus 8. And now, I look for like terms and simplify. Trust me, these are things you already know how to do. It's just easy for the brain to panic and shut down because we're using them in a different context.
Because of that u squared, it was parentheses x plus 4 squared.
Uh-huh.
Why didn't you substitute that in with that square?
What square? Over here?
No, go down.
There's no more square left. See, when you factor, you're getting rid of exponents. You're breaking down to linear factors. Huh?
The u squared is just to like make sure that it's like
Yeah. It's to check that, it's to check that it's,
It's just to check the answer.
But it's also when you do your first, but it's also when you do your first substitution, you do have an x to the 4 squared that you put in a u squared.
Yeah.
So you substitute both of these in originally, but once you factor, all the squares go
I
away.
did that. Okay.
Yeah. So you don't need this one anymore because there's no more u squareds.
Okay.
Yeah. Yeah, that really is just to check it, like you said, to check this quadratic in form, but then of course you use it when you make your initial substitution, but then it's gone by the end. All you need is this one to substitute back. And you're literally just plugging it in instead of u and using your rules of simplification. Distribute and combine like terms. And just, if you've got two binomials here, that's what you're going to have here too. So just plug it in just like you see it, and then this is one little package that's simplified, and this is the other little package that's simplified once you distribute it and combine like terms. But they're still two separate binomials. You just got to clean up each one inside. But they don't interact. Just clean up that one and clean up that one. And now they're in terms of x rather than in terms of u. It's okay? All right. Look a little stunned. Keep practicing. All right. So, the last factoring technique is working with binomials. Okay? Now, we spent a lot of time going over some of this stuff from homework and all, so I don't want to have to rush too much at the end. So what I'm going to do is I'm going to use what I already wrote out for my 8 a.m. class, and it will be scanned in and posted too. So you don't have to worry about writing everything down. The first thing I'm showing you is more of an overview. Okay? We wrote it all out together in the morning class, but like I said, I don't like to have to rush at the end. So we're just going to go over this overview, and I will scan it and post it as well. And it also kind of reflects what's going to be on the finished PowerPoint as well too, as I get that finished up. Okay. All right. So a lot of what the last technique we're working with is binomials. Okay. Binomials are really easy to factor because there's not a lot of math involved. They're more about recognizing what you have. When you know what you have, then you just plug it into a formula. Okay? So the big thing is understanding what you're doing so you know if your answer is reasonable, understanding why it works that way, and then making sure that you recognize what you have. Okay? But then when we get to the actual technique, it doesn't take that long to show that. So we'll spend some time here really working on the basis of things and understanding the concepts and understanding how to recognize what you have. So the overview, like I said, this is already written out, so I'm just going to sort of go over it, scan it in, so we can move on to more of the meat of things. But basic factoring overview is this. The idea that what factoring is, the concept of factoring is that you have a polynomial, which is a sum of terms, and you break it down into its factors, a product of factors. So you change it from a sum into a product. And as the arrow goes both ways, because you can always check your work by multiplication. Okay. So once you have factors, multiply them back, and you should get back to where you started. Okay? This is just a reverse process, an inverse process. Factoring and multiplication goes both directions. Okay? Now, step one, always, this is kind of your mantra of factoring. Because what's overwhelming, like I pointed out at the beginning, the factoring you've been doing, practicing on homework, has been broken up by types in little groups. But on the test, it's going to be a mixed bag. Okay? So that can be the most intimidating. Like I said, you really want to look at this review practice because it's going to show you how to look on the test, all mixed up. And so the most intimidating thing is like, where do I start? Well, that's exactly what your first question is, where do I start? And the answer is always the same.
GCF.
Yeah. Always ask yourself if there's a GCF. Always. Okay? You got to take a GCF out first if you can. Okay? There's not always one, but if there's one, you must take it out. There are a lot of times you can't even go further. You can't even answer the question about what else you have until you've taken out a GCF. Okay? Other times it's just as kind of an inconvenience if you don't, and then you have to deal with it at the end, and it's just messy and chaotic. But you can fix it. Other times you can't even fix it. You just can't move forward unless you take it out. So as a rule, across the board, that's where you start. Okay? Now, once you pull out that GCF is a factor. Therefore, it is part of your answer. It's part of your factored answer. So don't forget about it. Even if you set it aside for a minute, you're done with it. But it is part of your answer, so don't forget about it. You just don't have anything else to do with it. Okay? So once you pull that out, if there is one, then you have three choices. What you have left, out of all the infinite polynomials in the world, a polynomial is just a string of terms added and subtracted to each other. Out of all the infinite possible polynomials in the world, only a small handful of them are actually factorable. Okay? So your job now is to see, hey, what do I have left after I pull out a GCF if there was one? Is it factorable? And the ones that are factorable are either, well, count your terms first. This is one of those things, don't overcomplicate. If you have 4 terms, then you have a 4-term polynomial. And your only choice there is grouping. That's 9.1. Okay? Little GCF, big GCF. Okay? 4-term polynomial, grouping method, then you're done. Okay? Now, if you have a quadratic trinomial. Now, any 3-term polynomial is a trinomial. Okay? The only ones we can factor are quadratic trinomials. So if what you have left has 3 terms, and it is in this form, ax squared plus bx plus c, then you may be able to factor it. Sometimes they end up prime, but if it's not this, then you just move on. You're done. Okay? So, if a quadratic trinomial, there's 4 possibilities. One is that your A equals 1.
You're not done. Or
A,
you're
C,
done.
B,
You're done.
and you're done.
Okay.
Yeah, because that magic pair of numbers, the magic pair of numbers you get here on your X, that is your constants. X plus or minus this, X plus or minus that. So you just need to know your sign patterns, and you're done. Okay. Now, if A naught is not equal to 1, A, C, B, but you're not done. Okay. You use that magic pair of numbers to split your middle, and then you use 4-term grouping. Okay. So they start off exactly the same way, but your magic pair of numbers mean something different. Here they mean your constants and you're done. Here they mean your split middle, and now you 4-term group. Make sure you use the variable that is in the middle, whether it's an x or y or an xy or a u. That's your middle.
Okay.
Now your third possibility is that perfect square trinomial. Now if you end up with a perfect square trinomial, which is a nice special case, you can use, depending on whether A is 1 or A not equal to 1, you can just do it the long way. Okay? But I have strongly encouraged you to not do that, because understanding this pattern is going to really help you moving forward in different contexts. In fact, on the test, if you do it the long way, I won't take points off, but if you do it this way, you'll get extra points. Okay?
Oh.
Okay? Now, the basic setup for perfect square trinomial, notice there's no variables in this, because when I write out a formula, A and B just stand for terms that includes the variables. So example, A squared might be like 9x squared.
Okay.
Okay? So, but the setup, the basic pattern, the pattern or the formula for a perfect square trinomial is if you have a quadratic trinomial where the first term is a perfect square, that means the coefficient and the x are perfect square, and the last term is a perfect square, usually just a number. And the middle term, if you unsquare the first and the last, you have your A and your B, because the unsquared square root is the mathematical term for that. And then if you have your A times your B and you double it, and that equals your middle term, check. You have a perfect square trinomial. A perfect square trinomial is of the pattern where your first and last terms are perfect squares,
Okay.
and your middle term is your A times your B doubled, because it's a binomial times itself.
Okay.
Okay?
I like that.
And remember, a binomial times itself is A times A on the front end, and B times B on the back end, and the middle term, the O and the I in FOIL, is AB plus AB. A and B are the same, so AB plus AB just means 2AB. Or AB doubled. Make sense?
Yes, ma'am.
So that's the pattern. So you don't have to expand this out and multiply it when you're multiplying a binomial squared. You just have your A squared on the front end and B squared on the back end, and your middle term is your AB plus AB, or A times B doubled. So if you're given this and you say, oh, that's a perfect square, that's a perfect square, well, make sure and test the middle term, because it still might not be perfect square trinomial. Once you find your A and your B, double it. And if it matches this, check. Then you're done. You know your A and your B, and you just write A plus B squared or A minus B squared. And whether it's plus or minus depends on the middle term. Remember, these are either both, if this is a binomial squared, they're either both plus or both minus, which means 2 pluses multiply to make a positive, 2 minuses multiply to make a positive. So this is always positive on the end here. Whether this is an A plus B or an A minus B depends on the middle term, if it's doubled or negative doubled. If it's plus, this is plus. If it's negative, minus, this is minus. But it's a binomial squared.
Okay.
Special case, if you show me that you checked it like this and then immediately plugged it into your binomial squared, extra points. Okay? And even better than that, it's really going to make things easier by the end of the semester. All right, and your fourth choice, if you have a quadratic trinomial, is it may be quadratic in form. Okay, as we just showed on those homework problems, you set u equal to the middle variable. Okay? And if u squared is equal to the first variable, square both sides, and if that equals the first variable, then check. You have quadratic in form, and you use u substitution. Okay? Just like we just demonstrated. Okay? Is that okay?
I just want to.
Okay. Now, I'm going to post this, so don't worry. Don't try and worry about having to write all this down, okay? You can. I will post this afternoon, so you will be able to see it, okay? And you can fill in your own notes and rewrite it your way for, definitely rewrite it because that helps you remember it, okay? But don't panic, okay? So, and also I will leave it out here, so if you want to photograph it before you go, you can do that too. Okay? All right. All right, so to continue the overview, what we're working on today, here's an overview about what we're about to do, because Just like I said, the mantra, the first thing you always ask yourself, oh, I have to factor, where do I start? GCF, boom, always the same answer. If there is one, take it out. And then your next question is, okay, what do I have left? 4 term, use grouping. Quadratic trinomial, use, depending on one of these 4 things will happen if it's factorable. Okay? Or, if you have 2 terms left, that's what we're doing today, then you have either a quadratic or a cubic binomial. Binomial for 2 terms. Okay? Now, there are 3 possibilities, or rather 4 possibilities, for a quadratic or cubic binomial. Okay? Now, binomial again means, remember, 2 terms. Now, there's infinite number of binomials in the world. Most of them are not factorable. But if you have one of these setups, then you may be able to factor it. A difference of squares is exactly what it sounds like. Difference means subtraction.
Squares, and they're squares.
Perfect square, and that includes variables. Remember, this sort of formula form, the variables are assumed. Okay, so there could be x's and y's in here. Okay, just the first term is a perfect square, both the variable and the coefficient, and same with the second one. And if you got a perfect square minus a perfect square, you don't have any more math to do. Your only math was recognizing that's not what you have. That's it. You unsquare to find your a and unsquare to find your b. That's it. There's no middle term like with a perfect square trinomial. When you know this is what you have, it factors into its conjugates. You already know your a and your b from testing it, so boom, a plus b, a minus b. Those are what's called binomial conjugates. Okay? It's where your a and your b are the same, but one's plus and one's minus. This is not a binomial squared.
Okay, so
Binomial squared would be both pluses or both minuses. A binomial squared is a binomial times itself, which means they both have to be plus or both minus. And if these were both plus, you'd have a positive b squared. If these were both minus, you'd have a negative b squared. And you'd also have a middle term. But if one's plus and one's minus, that means this has to be negative. It's b times b, which is squared, but mixed signs, so it's minus. Now, why isn't there a middle term?
yeah, so it's gonna have.
Okay, well, a squared for f in FOIL, and b squared minus b squared for the L in FOIL. But what's my O and my I?
They cancel out.
They're both AB, but one of them's negative and one of them's positive, which means they
Cancel out.
cancel out. So there's no middle term. Okay. Now, if you have a perfect square, but there's a plus, that's a sum of squares. That's prime. And your I will say, oh, perfect squares, and you want to put it in conjugates? You got to check not only that they're perfect squares, but what's in the middle. Subtraction, conjugates. Plus, prime. Because if these are one positive, one negative, then you're going to have a minus b squared. Mixed signs give you a minus b squared. Okay, so that wouldn't be plus. And if these are both pluses or both minuses, then you have a binomial squared, and you have a perfect square trinomial with a middle term, a doubled middle term. No middle term here. There's no construction of A and B
Yeah.
that's going to give you this. Okay?
So you just write prime?
So you just, because you can't do anything with it. Yeah, fine, you're done. Yeah, because there's no setup of A's and B's. 2 pluses or 2 minuses would be a binomial squared with a middle term. 1 plus 1 minus gives you a negative, no middle term, but a negative b squared. There's nothing you can do to get this. So it's prime. Okay? And the third, third and fourth, are sum and difference of cubes. Both of those are factorable. That's not prime, so it's either perfect cube plus a perfect cube or a perfect cube minus a perfect cube. And either way, this is a little trick. This is the formula. If you have a sum or difference of perfect cubes, it factors into a binomial times a trinomial. Okay? And the binomial is just your uncubed, both of those, and it's your a plus or minus b, and your trinomial is the a squared plus